All right, here we go. We have 6, 4, and today we're going to be talking about rectangles. All right, so a couple of things that we want to know about a rectangle. We're going to write our basic definition first, which probably most of you know. A rectangle is a type of parallelogram with 4 90-degree angles. Alright, so you should have a glue in. It kind of looks like this L shape. I'm going to cut across here. Doesn't turn out perfect, but that's okay. There we go. I'm going to glue that in there. Set the other part one side real quick. Alright, and as I look at this, there's a couple things that I know that as I look at it. Okay, in this first one we have this rectangle. So as I look at that rectangle, since it's a parallelogram, we know in all parallelograms, opposite sides are congruent. So this side is congruent to this side, and this side is congruent to this side. Okay, and then we also know that we have those 90-degree angles. So 90 degrees, 90 degrees, 90 degrees, 90 degrees. Okay, that's our basic idea of a rectangle. But what we also know here is that diagonals are congruent to each other. You can't see that. There we go. Sorry. Diagonals are congruent to each other. So if I look at this picture here, my diagonals, I have A to C would be congruent to B to D. And what else I know then is that, remember, in a parallelogram, this also bisects each other. So AK is the same as KC, but then AK is the same as KC, and that's really AC. But then as I look at BD, BK is the same as BD, and we know that those were the same. So we can now say is congruent to BK, which is congruent to KD. Yikes. All right, now as we look at this, there's a couple other things that we want to keep in mind. If I look at these two triangles here that are created, I see this triangle that's across from this triangle. Those triangles end up being congruent, and they're isosceles. So remember with isosceles triangles, we know that we have congruent angles. So angle A here would be congruent to angle B. But then this is also the same, so angle D would be congruent to angle C. Now we can't just use one letter because there's more than one angle at angle A. So we're going to say angle BAK is congruent to angle ABK. That's the one down here because B is in the middle. So ABK which is congruent to, now moving over here, I can do KCD, that's a C. Start at K, go to C, up to D, KCD, and I could do CDK. Oops, I forgot my angle here. I'm getting a little tired, sorry. Wake up. Alright, we're going to do an example all with this second sheet of paper here. So if you're going to go ahead and glue that in. We have 3 examples that we're going to do with this one. One that's really easy, one that's medium, and one that's a little bit more challenging. Alright, so for our first one here, I'm going to say if GK is equal to 6 centimeters, what is JH equal to? So if I look at GK, GK is this side, and I'm looking for JH, which is the opposite side. And we know in a rectangle, opposite sides are the same. So if this side is 6, this side is also 6. So JH equals 6 centimeters. Done. Crushed it. Alright, that was our easy one. Now let's do our medium difficult. Difficulty number 2. If KH equals 26 centimeters, how much is MJ? So I'm going to be looking at K to H. So K all the way up to H. I'm looking for this MJ. So first thing I know is KH is the same as GJ. And we know all of these are the same. So if I know the whole thing is 26, all I need to do is find out what that would be cut in half. Because it bisects, it cuts it in half. So I'm going to take 26 divided by 2. And I get 13. So all of these are 13. So MJ is 13 centimeters. Alright, last one. Number 3. This one's our more challenging one because it's going to be about angles. So we have to really make sure we're reading carefully, we're looking at that picture carefully. It says if measure of angle JKH is 27 degrees. I want to know what is the measure of angle KGM and I want to know what is the measure of angle KMJ. So it's really 2 problems. Whoops. But we're going to pretend it's 1. Makes it more fun. Alright, so first thing we're going to do here is find those angles. I'm going to look for JKH. So if I trace that JK all the way up to H, I'm looking for this angle here. So that angle is 27 degrees. Then what I'm trying to find here is KGM. First off, do those ones match? Nope. But what I do know is in the corner here at angle K, I know that that is a 90-degree angle. And there's a cut in the middle there that says that this is 27 degrees. So how many degrees would that other one be? Well, we would take 90 minus 27. 90 minus 20 is 70. 70 minus 7 is 63. Yep, 63. So I know this inside angle now is 63 degrees. And that angle now matches that angle. So if that's 63, then this is also 63. So the measure of angle KGM is 63 degrees. One more, just cause. Miss Muriel likes to torture you. Just kidding. We have KMJ. Alright, so KMJ. KM, oh my goodness, J. So this inside angle here. Woo! Alright, so let me look at that as a triangle. So I'm going to copy that down over here. So I have K, M, and J. And my goal is to find out what this is at, this M. Okay, we knew this bottom one was 27. And remember, that means that this J is also 27. Oh, now it's just a triangle problem. We've done so many triangle problems. So we know they all add up to 180, so we can just do 180 minus 27 minus 27. Some of you really love to add 27 and 27, then minus 180. I'm lazy, so I just like to do 180 minus 27 minus 27. And we get 126. Which it definitely doesn't look like it's 126, but oh, we're going to pretend it is. Just kidding. Not pretend. It's in real life. Because the picture isn't always right. Oh, you can't see that. Love it. Beautiful. Alright, that is it for the notes. There is a practice today, so make sure you open that up and get that done. You're amazing. Miss you.